Okay, so today I'll be doing some more practice. It's not on Alchemist this time because I kind of already finished like three of the subjects on Alchemist. I want to take a small break on that, work on the textbooks, and then keep progressing there before I continue with Alchemist. Today we're going to be doing some AIME type of questions, not from the actual AIME exams. Let me switch to the regular scene. Not from the regular like actual AIME exams, but rather from um, sample or kind of practice tests made by the Berkeley math tournament, which I found earlier today. So I thought I'd just make a video of it. I've tried a few of these questions, not all of them. I actually have seen like maybe like one or two of these, so not many of them. And yeah, so just like the AIME, there are 15 questions, 3 hours to do it, and no calculator, none of that. All of them I think are integers from 0 to 999. And yeah, I mean, so just we'll see how many questions I can do. It's been a long time actually since I took the AIME, and even longer since I studied for the AIME, probably like almost like 8 months now. That's kind of when I took it. So I'm not expecting the best here, but I'll still try, and we'll see how well it goes. So let's start with the first question. There are two geometric sequences. So the first one is 16, a sub 1, a sub 2, and so on. And the second one is 56, and then b sub 1, b sub 2, and so on, with the same common non. Because that's the case, we can do like a, right? We can do this. So if we do this, we get a to the 20/22nd. And so logically, and this is equal to what? B to the 20/20th. So if we divide these both by r, this will go to 2 to the 19th, 2 to the 2009, b sub 2019. If we make this 2020 and we make this 2020, now we get a much simpler and easier ratio. This is going to be a sub 3, I think, and this is going to just equal b sub 0, and b sub 0 is 56. So now we know we've got 16, 16r, 16r squared, and then 56. So 16r cubed is equal to 56. What do we do from here? Well, what are we asked for, right? I mean, we can find r, but it's not going to be very pretty. What they're asking for is b sub 6. So b sub 6, we can find r cubed, right? That's probably still useful to do. This is 56 over 16. But b sub 6 is nothing but b sub 0 times r cubed squared. And similarly, a sub 6 is nothing but a sub 0 times r cubed squared. We're given b sub 0 and a sub 0. So the first one is going to be 56 times 56 over 16 squared minus 16 times the same thing. Of course, this factors out, like we can factor out a 56 minus 16, so that's 40 times this. Let's take out a 4. You can take out a 4 over here. No, you're gonna get an 8. You get 7 over 2 and square that. And what do we get now? Now we have 49 times 10, which is 490. So that's our answer for the first one. So 1 is 490. That means I go up here on the top and write my answers down. We're probably not going to get very far, so I'm just going to leave 5 for now. Hopefully we'll try these. My goal is to try all of them. I don't know how well I'll do on them though, right? So we don't expect like any high score here. It's for a very long time, and I'm going to be practicing very diligently for some time. Okay, this one doesn't look too bad because it's a rectangle and it seems to be, the Pythagorean theorem works here. So that's A, B, and this is 6 or something like that. Oops, that's C. This length is 6, this is 8. D, so this is 8, this is 6. And I'm going to move the 6 out here because they're in a circle. Because we're in a circle, the radius of the circle is going to be 10. But that's not what they're asking. They're asking us for, okay, so this is center O. Let M be the midpoint of side AB. And let X be the intersection of ray MO with the circle. So that's going to be like all the way down here, right here. That's X. They're asking us for AX squared. So that's pretty easy, isn't it? It's just a right triangle. If this length over here is 8, this is going to be 4. So this the diameter is going to be 10 because it's 6 squared plus 8 squared, square root of that. If the diameter is 10, this is the center point. A chord passing through the center is a diameter, so this entire thing would be 10. This part here is 6. Well, I mean, okay, enough ways of doing it. Um, yeah, but like, so this is going to be 3. This is going to be 3. That's 6 together. This part is symmetric and congruent to this part. And that's, so this is going to be 2. This is going to be 3 and 3, so 6 in total. So, I mean, yeah, I guess it's probably easier if you just think about it, draw it out for yourself. What we end up with is something like this. And what's the distance here? It's going to be 4 squared plus 16 squared because it's ax squared. So we don't even have to take the square root of that. And that's 16 plus 64, which is 80. Nice and easy question there, I think. Definitely not as challenging as the first one, even. I mean, yeah, neither of them are particularly hard. It's just that this is a little easier because it's just literally a drawing and then simple calculations from there. Let's try number 3. This one I've never seen before. Given positive integers a is greater than 2 and k, let m sub a of k denote the remainder when k is divided by a. Okay. Compute the number of positive integers n less than 500 such that, okay, so you leave a remainder of, so you want something that leaves a, okay, um, so I guess what we can do here, because it's m sub 2, because it's a remainder of 1, that means that this has to be odd, I think. Or, I mean, yeah, you can write this, I'm sure this can be written better, is congruent to 1 mod 2. Given positive integers a sub 2. Okay, so a is greater than 2, that's fine. That's nothing special there. We just need to find how many possible k values satisfy this. Less than 500. Okay, so we want something that is enough more than a multiple of 11 that it gives us, well, no, we don't have to do that, right? So this can, okay, wait, let's actually do this, right? So m sub 5 of m sub 11 n, this can equal 1 3 5, something like that, right? Like, I guess if we're doing it like this, it should also be able to go into the negatives, no? um I don't know, but yeah. And so it's going to be congruent to all of these different numbers modulo, so it's congruent to 1 mod 5, it's congruent to 3 mod 5, congruent to well, it can't be congruent to 5 mod 5 now, can it? Yeah, that'll give you 0. So that, wait, okay, yeah, I think I'm going about this the wrong way. Let's try to find a slightly better approach because I don't think this is really going to work out. I don't see it as um being useful right now. Let's think instead, right? Like, if we have something like 12 works, right? And the reason I'm starting with, well, I mean, I shouldn't start with 12. I can start with 1 itself. 1 will work. 2 will obviously, not work. 3 will work. 5 will not work. What about 6? Will 6 work? Well, obviously not because it's even. 7, no, 7 also won't work because it's m sub 2 of 2. So 7 doesn't work. So what we're noticing is that, okay, no, so modulo 5, um, it has to be congruent to 1 modulo 5, right? 1 mod 5, or it can be congruent to 3 mod 5. After this, you can't have 7 mod 5 because that would be 2 mod 5. You can't have 9 mod 5 because that would be 4 mod 5. So, right, you can have 0, which obviously won't work, 1, which does work, 2, which does not work, 3, which does work, 4 does not work, and 5 is the same as 0. So, these are the two options that you do have. Now, we want to go one step out from here as well, right? You want to have it so that it leaves you, um, um, you want it to leave you a remainder of 1 mod 5 after you divide it by 11. So that's like 1 plus 5x should equal 11 something. So what are the possible moduluses or moduli or whatever that you can have? So what will n equal? Let's like kind of brainstorm a little bit. You can have obviously 1 mod 11, right? And when you have 1 mod 11, that's going to give you 1 and then 1 mod 5. So 1 works, 2 would not work. Right? 1 mod 11 is 1 mod 5. Yeah, yeah, yeah. Well, no, that's never going to work. So it needs to be. Hmm. Like, yeah, I mean, 3 will work again. How about 5? Oh, wait, what about 6? Yeah, so 6 will work, and then so will 8, right? 8 mod 11, and then is there anything else that you could have? You can have 11 mod 11, but that's kind of covered already. So, no, you can't. Because that would be 0, right? And then you obviously 10 mod 11 won't work. So these are what I see as the possibilities mod 11. Right now, let's try something. So, um, uh, let's go with, oh, actually, yeah, this seems to hold for the first few values. If you plug in 1, it's going to work. If you plug in, it's like basically 11x plus 1, 3, 6, or 8. So when x is 0, we're going to get 1, 3, 6, 8. Then we're going to pop over to 12, 14, and then, like 17 and 19, something like that. And all of these do seem to work, right? Let's try 17 at random and see. So 17 mod 11 is 6, 6 mod 5 is 1, 1 mod 2 is 1. That works. 19 would be very similar. It would give you first 8 and then 3 and then 1. So all of these work. So what is our lesson from this? Every 11 numbers, you're going to have 4. Every 11 numbers, you're going to have 4. And how do you find? So yeah, we're going under 500, right? So 484 is a multiple of 11. This is equal to 11 times what? Times 44. Meaning 490, yeah, so 495 is 11 times 45. We have 4 11ths of 495. All of these will work. And so that's going to give us 45 times 4, which is 180. And then what after that, right? After that, we're going to get 495 plus 1, 495 plus 3, 498, and then we're done. So it's going to be 182. And I think we're done with that. Yeah, I mean, I don't see. Yeah, you're right, Rohan. Sorry, I didn't see a message until now, but that's what I ended up doing. So I'm not gonna check the answers yet, but what did I say? I said 182. Yeah, I mean it wasn't that hard in the end. I think I was just overcomplicated in the beginning. 182. Let's go with green for the next one. Let me stay zoomed in. I don't want to waste too much space here. Okay. Compute the sum of all positive integers n for which there exists a real number x satisfying this. Um, So, okay, first thing I notice is that give me 1 second. My doorbell is ringing and no one's opening it, so I need to handle this. I'll be right back. Sorry about that disturbance. I'm back now. Yeah, so the first thing wait, let me just check that I'm unmuted. Last stream I was muted for 40 minutes until I realized my mistake. So let's see. Um, all positive integers n for which there exists a real number satisfying this. So we can take the 2 out, I mean the n out in front. We have log base 2 of x plus n over x. And so, okay, well, think about it like this, right? This should be fine. This is an integer, right? And if that's the case, oh, I see, wait. Must this also be an integer? Um, so initially I was thinking, oh, well, obviously n's going to be an integer. Then this will also be an integer. That doesn't have to be the case. So like, what if this is 40 and then this is 1/2? That'll also work. Let's see if that's possible though, because we're given, um, okay, well, let's keep that in mind for now, and we'll hold on to that. Let's simplify this, or I don't even know if this is simplifying. I'm just trying to see if I can get anything useful here. And so we're going to find eventually x plus n over x is 2. We can actually express this as a quadratic, can't we? If we multiply everything through by x. So x squared minus 2 to the 20 over n x plus n is equal to 0. And what we want here now are integral solutions of this. So what integer values will work? Uh, so what we want here then is we're going to find all the possible integers n in this range such that, and we're going to see what the such that is in a second. This can be written as x minus 2 to the 20 over n minus 1, right? Because it's 1/2. This is after dividing it by 2. It can be written as this squared plus n minus this thing over here squared. So what is this going to give us? It's going to give us 2 to the 20 over n minus 1 whole square is equal to 0. And so what we want here, this is a perfect square. So this has to be less than 0, right? So we want, yeah, we want this to be less than 0. Meaning, in other words, that n has to be less than this squared. Oh, well, no, and if you're squaring it, then that makes it 40 over n minus 2, which can also be written as 1/4, and so we can put the 4 over here. Now we just check integers, right? And eventually we're going to see something that, doesn't work anymore. Does 1 work? Well, obviously 1, let's just like list out the possible values of n. Obviously 1 should work here. 2 should work, 3 should work, 4 should work, 5 should work. What about, right? Because at this point we're still like, this is going to be 20, this is going to be 2 to the 8th. So big difference there. What about something like 6 or 7? With 7, this is now 28. This is still over 2 to the 5th, right? It's like, yeah, I mean, so 7 is definitely going to work as well. 8 is where it gets a little bit interesting. 8 works to the point that, yeah, I mean, so 8 is not strictly less than that. 8 is equal to that exactly. And I just want to make sure that that works in the context of this question. It should be fine. I don't think there should be any issues with that, but just in case, right? So let's keep these ones here for now. Let's think about 8 though, because that might end up giving us some trouble. I this should work. Like, I mean, it should work just because over here, this can also equal 0, right? In which case x will equal 2 to the 20 over n minus 1. And I'm sure that's fine. In fact, yeah, let's just test it out, right? So what would that give us if it's 8? It'll give us x is negative 2 to the fourth. So it would be yeah, x minus 16 is equal to 0. So x is equal to 16, I think. X is equal to 16. Let's try that. 8. So that's what we're testing. So actually, let's just do this. X plus 8 over x times 8 is equal to 20. So what is 20 over 8? That's 5 divided by 3, I think, right? Oh no, I think I messed that up. It's 5 over 2. Good catch there. Log of x plus 8 over x base 2. So now we do 2 to both power is equal to this. So x plus 8 over x is equal to 2 to the 5 halves. 2 to the 5 halves is nothing but 4 root 2. So we have x squared minus 4 root 2x plus 8 equals 0, which is x minus 2 root 2 squared perfectly. So x equals 2 root 2. Okay, yeah. So whatever I got earlier, then that obviously the 16 number is wrong. Not sure where that came from. Yeah, no idea. I messed something up, but this seems to work. So 8 should also be an answer then. And then it's just a sum from 1 to 8, which is 1 plus 8 over 2 times 8. So that's 4 times 9, 36. Right, so it's just a sum of all of these. Okay, that's number 4. We've taken quite some time here now, but at least we're making some, a little bit of progress. I want to go and renew this with the 6, 7, and 8. Let's see how far we get. I'll work over here now, change up the colors again. Let's go with like blue this time. Okay, Kate rolls a fair six-sided die until she rolls a 6. If she rolls a 6 on the nth roll, she then rolls a die n more times. The probability that she rolls a 6 during these next n times is m over n. And then, yeah, so find m over n and then just put in this format. So let's see. Maybe she can take one turn, right? If this is the case, it's going to be 1/6. Yeah, it's going to be 1/6. And what if she takes more than this, right? What if she does Um, okay, so let's just do cases, right? Like, and they're going to be infinite cases in the end, but so case one, this is one turn. I'm just using this to get like an inspiration for the rest of the question, and then we'll hopefully notice some pattern because there has to be some sort of pattern here, right? One turn, so there's a 1/6 chance. You have to get a 6 immediately, and then you're going to have another 1/6 chance after like post factor. So this is actually, let's make a nice little table here. This is case one has a probability of 1/6 of occurring, right? And so it's gonna be whoa, 1 second, 1 second. It's got a 1/6 chance of occurring, and then after that, the chance of getting a 6 is in one turn is going to be 1/6 again. And actually, we can think of this in a better way as I want to rewrite this. It'll be 1 minus. Wait, why I want to get rid of this dot here. Okay, I'll just do it like this. Yeah, so just so that we're more systematic with this. So okay, this is going to be 1/6 times 5/6 to the 0 times, and here we're going to have 1 minus 5/6. No, sorry, 1 minus, yeah, times 1 minus 5/6 to the 0. Obviously not the case, to the first power. Yeah, I think that's it. And I think this is going to be our general rule for everything. Because now in the second turn, to get it in 2 turns, you're going to need 1/6 to get it on the second try, but the first try can't be a 6. So you need a 5/6 chance of that. And the probability that you get a 6 on either your first or second is going to be 1 minus 5/6 squared, right? The probability that you don't get a 6 on either. And that's how it's going to continue. So this is going to go on forever, right? And let's see the general rule. So we have 1/6 times 5/6 to the, let's say, n minus 1 times 1 minus 5 over 6 to the n. That's what we have. Obviously, this, there has to be some sort of nice simplification that occurs here, and we will look at that. But let's see. So yeah, I mean, now it could take you 100 turns, and what's the probability of that happening? The probability of it taking 100 turns is this, which is exceptionally low. But the probability of you getting an n after the 100 turns is going to be very, very high from here. So there should be, so hopefully this will resolve, is what I'm kind of getting at. Now what we need to do is figure out a way to sum this, right? So we want to sum this from n equals what, 1? I think we started with 1, right? Yeah, so n equals 1 until infinity of this mammoth product over here. So that's exactly what we'll do. Let's take out the 1/6. That's pretty simple. And now what we have is well, okay, we've got 5 over 6 to the n minus 1 minus 5 over 6 to the 2n minus 1. So what does this tell us? Well, it's, does it seem right? Yeah, I mean, it seems fine. So one way we can kind of maybe think about rewriting this is as, okay, maybe this could work, right? This is going to be, um, it will be 6 to the n times 5 to the n minus 1 divided by 6 to the n times 6 to the n minus 1, which is 6 to the 2n minus 1 minus this thing over here. And what I'm doing now is kind of moving the exponent inside, so it's a little bit more, useful for us. This is a 2n minus 1. And now at last I think we're beginning to maybe see something. Yeah, okay, now I think I maybe have an idea now. 1/6, this is n equals 1 to infinity. We can take this out. Well, I mean, we can't take it out fully yet, but we can at least do this. And now what we have is 6 to the n, 5 to the n minus 1, minus 5 to the n, 5 to the n minus 1. Just breaking it up a little. Obviously, this is now in common as well. And so when I say this, I mean the 5 to the n minus 1. Oh, yeah, I mean, it doesn't seem to be looking that good for us. 6 to the n minus 5 to the n. How do we sum this? Like, it doesn't seem easy. Unless, I'm sure there's something like pretty basic here that I'm missing. But I don't know. Maybe we can move in that 1/6 here again and kind of make this a 6 to the 2n in case that helps. But I'm not sure if that would really be helping us. So maybe now we can kind of look at some early cases, right? So let's plug it in and see what we get. We're going to have, um, hmm. Well, okay, I mean, if we shift the bounds a little bit, we're going to get something at least a little bit neater, right? Like just a tad bit neater. What I mean by that is, so let's actually take out another 6, right? Another factor of 1/6, I mean, which is going to go and make this. Okay, wait. We can, yeah, let's do this. So I'm moving the 1/6 back into this because I think it's actually better in better place over here, right? And so it's going to be 5 to the n minus 1 over 36 to the n minus 1 because the 6 will make this 2n minus 2, which can be rewritten like this. And now it's 6n minus 5 to the n, 6 to the n minus 5 to the n. How do we proceed from here? So I mean, obviously we can kind of, Yeah, I mean, at this point, I think we can really just begin to plug in some values and see what we get. If n is equal to 1, we will have 1 plus, now it's 5 over 36 times 2. No, I mean, there has to be an easier way to do this, right? There has to be some way that you can actually simplify this. I just can't. Wait, there's a formula for this. It is 6 minus 5 times something. It'll be, I think it's, yeah, I mean, it's like 6 times n plus 1 plus, sorry, n minus 1, obviously, plus 5 to the first times 6 to the n minus 2 plus 5 squared 6 to the n minus 3 and so on. And that's going to continue all the way until we get 5 to the n minus 1. Now, is this correct? I think so. I think this actually works, which is good. How does this help us? I don't know. Well, I mean, this is just a 1. So, okay, maybe this actually does kind of help us out in the end, right? Because we know that, no, I mean, I really don't, um, hmm. 36 minus that, this is going to be 11, and then we have, yeah, I mean, already with the cube, it's going to get like pretty messy, I think, I feel. So, is there any like simplification we can do here? I don't know. It's I think okay, maybe you're fine in the beginning when we did this, when we did the first case, but this entire summation thing, I don't think I'm good enough at summations to like do justice to this. So let's perhaps consider an alternative approach, or let's put that question off and do something else. Let's try some geometry. We've had success with the one geometry question that we've done, so maybe we can replicate that. There are a few geometry ones. There's 6, 8, and then 10. So let's try 8 first. 8 is obviously not going to be super easy. Actually, let's try 6. That seems easier. For the reason that it seems to be a right triangle because of the side lengths given. So this is like 8, 15, and 17. Okay, let's see what Rohan's saying. I think what you're doing is setting the b square minus 4 is c. Yeah, okay, so that was the last question. For the current question, back when you first introduced the summation sign, I think you can take out a 6 over 5 from 5 over 6 to the n minus 1. Let's pop back there and check. So when we first introduced it, you can take out a 5 over 6 from that. Yeah, you can. We can. Yeah. Okay, so let's do that. Not a 5 over 6. Yeah, I think he said 6 over 5, and that is correct because it's 1 over that. So if we take out a 6 over 5, that makes it 1/5, 1 to infinity, and now we have 5 over 6 to the n minus 5 over 6 to the 2n. Okay, wait, is this? Oh, no, we don't need to combine them at all. We can just, yeah, that was pretty stupid of me. Let me close this. I think we can just proceed and break it up into two different things, right? Like, there shouldn't be any issue with that. We now have, so let's take out a big 1/5. Yeah, okay, but this is kind of completely my fault. I'm kind of dumb for this. 5 over 6 to the n, which is just a geometric series, minus another geometric series. Break it up into two. They don't have to be in the same thing. And this is going to end up being 25 over 36 times to the n. So that's perfect. It's literally just two sequences now. First, sorry, geometric series or whatever. Yeah, I mean, this is going to be the first one. And then we're subtracting off the second one, which is going to be this over here. I hope I'm doing the formulas right. I think I am. And there's a 1/5 in front. So let's not forget that. 5 over 6 over this, that should just be 5, right? Yes, that's 5 over 6 over 1 over 6 of 5 minus, this is going to be a little messier. I think it's 25 over 11. Yes. Yep. And so that's um 30 over 11. There's a 5 over there, so this is 6 over 11, which means 17. Is that what our answer was? That's what they're asking, right? Yeah, 17. 6 over 11. The probability that she rolls a 6 during these next n times. That seems realistic as well, right? It's like roughly a half chance. So that doesn't seem like too, like strange. What was our answer? It was 17, I think. We'll see. Like, if the answer is slightly off, or actually it won't be slightly off. If the answer is very different, we can always check our calculations again. But I don't think it's that bad. Let's look at this one now. A, B is the smallest one. So this is right. This is 17. This is C, 8, and 15. Circles W1 and W2 are externally tangent to each other, and within this, the radius of W2 is 4 times. So sorry, not W, omega 2 is going to be significantly bigger. So it's probably going to go over here. It's going to thicken that circle a bit. Just like this, perhaps. It's a little intersection there, and then the smaller one. Ooh, yeah, I mean, let's just draw it like this. That should be fine. So, okay, one of them is 4 times just because the other one sure doesn't look like it, but we're going to go with that. The radius of that circle is 4 times the other's radius. It's tangent to AB and BC. Oh, wait. Oh, no, no, they're within. Okay, so I've drawn it wrong. So it's not the case then that I'm going to also zoom out a little so I can draw it bigger. So this is ABC. So the first one, omega 1, is tangent to AB and BC. So that's going to be a small one over here. Something like that. The other one is tangent to BC and CA. So it's going to be over here. And it's going to have also 4 times the radius as we just saw. Okay, so I think that's a better drawing. Let's proceed from here. The radius of circle omega 2. So this is omega 2. This is omega 1. Is 4 times the radius of the smaller one. Circle W is tangent to omega 1 is AB and BC, and then this one is BC and AC. Perfect. The radius, oh, okay, so we have to find the radius. Fine, that should not be, no, I don't know why I'm saying that. It could be very difficult. But, so if we do something like this and then something like this, will this make our work easier or harder? Let's kind of, we want to find the radius, and we know this little bit here. This is obviously going to be, so let's call the radius. Okay, wait, which one do we want? We want, so I want to call, we're going to find for R, but I want to call this R instead because that seems a little bit easier to me. That's the only, so if that's R, this is for R, this is for R, meaning that this over here is, so that's 4R, but this length over here is 3R. If that's the case, this is going to be root 7R, right? Root 7R. Now, how does that help us, right? That's kind of the question that we should be asking here. And, well, maybe we can kind of leverage the fact that this is tangent and that this is tangent to do something. Right now, what can we do about this? Um, Maybe we can. So I'm guessing similar triangles might have a role to play here, or at least something to do with the fact that we're inside a triangle, right? Otherwise, they wouldn't. And especially considering that they've given us the side lengths, so and that it's a right triangle. So there has to be some something that we can do with that. What exactly it is, that remains to be seen. let's kind of mark this out clearly. Um, okay, so we managed to relate some of the information here. Let's think about the angles that we have. This is going to be a right angle over here, right? And if that's the case, we know that it's a square because they're all right angles. Oh, no, that's not true at all. Mm-mm. It's a rectangle. This is going to be R, this is going to be R, this is going to be 3R, and no, sorry, that's also R. Oh yeah, no, it is a square, my bad. This is also R. Yeah. And is there something similar that we can do over here? I don't think so, but at the same time, we do know this piece of information that these two triangles are going to be congruent to one another, with this being 4R. So if we can maybe kind of do something with that fact, that will be great. Similarly, okay, maybe now we can draw this over here, which is a tangent, meaning that we get right triangles. This is one of them, and then this is the other one of them. What exactly can we do with these right triangles? Well, so we can probably connect this part and see. I'm not actually sure where exactly we're going with this, so we do need to kind of stay on point. Okay, these two triangles are also going to be tangent to one another. So, and okay, it's not that bad. Okay, wait, I see. So because this length is 8, this length over here is going to be nothing but 8 minus r, right? It's going to be 8 minus r. If that's the case, that's going to be the same thing as this, but we know that this is the same thing as this, right? So that should hopefully be of some use to us. At the same time, at the same time, we know that what do we know? We know that this is that's r root 7. So this entire thing is going to be 1 plus root 7 all multiplied by r. So we can find some ugly expression for that, from where we can equate that with what we get for this. Right, so there's some equations that I think will be forming. So let's do that now. What is 8? Oh, wait 1 second. We have to be a little bit careful. No, 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 we don't. Because these are all the same triangles. Mm, yeah, so just because of this fact that we see over here, so that pretend that's a straight line. Those two are similar, not even similar, they're congruent, completely congruent, as are these two. So this has to be 8 minus r, which tells us that this length here has to be 9 plus r. But at the same time, what else do we know? We know that this length over here is going to be 15 minus r times 1 plus root 7. So that's a little equation over there, I see. And it doesn't seem like a... mm, yeah, I might regret saying that. I don't, first of all, are they necessarily congruent? Yes, they should be because we have, well, no, what do we have? We have ASS, right? And that doesn't guarantee congruence, does it? Or yeah, like SSA. Um, let's go with it and see if we get a reasonable answer. And if we do, then we're fine. Because I'm sure there has to be something like that at play over here, right? So let's stick with this for now. Let's equate. So bring everything onto their respective sides. So we get 6 is equal to r times 2 plus root 7. So from here we see that, yeah, I mean, this seems like a shortcut, and if it's a shortcut, it's probably incorrect because they aren't just like sitting out giving handouts. Isn't this negative? No, never mind. So 6 times root 7 minus 2 divided by 3, right, from root 7 minus 2. Yeah, that's correct. So 2, so 2 root 7 minus 4. This is definitely not right. Yeah, obviously that's not right. This is, it should just be a neat fraction. Like 4r is not going to be any prettier than this. So obviously something's the matter with this drawing over here that we have. Maybe it would help to draw it a little bit bigger. So let's actually go and do that. Um, yeah, so just draw a nice old triangle like this. Try to be a little bit like more realistic with the way I'm drawing it. So this is going to be a small circle, and something like this would be our second circle. Yeah, I mean, obviously I can't draw it perfectly, but at least let them touch there. Okay, that's not looking too terrible. We're going to go with this as a circle. Let me kind of erase some of it. It's not going to be easy to erase on this without removing the whole thing. Oh, wait, it is. Okay, perfect. Yeah, not bad. Let's now see what we can do. So this is going to be the center of this circle. This is going to be the center of this circle. We know that this is going to have to be a square because this is a right angle right here. And we also, the reason we know it's a square specifically is because this is the radius. And if that's a radius, so is this, and so is this, and so is this. We then know that this length over here is 8 minus r. No, no, no. Okay, no. What I was saying earlier isn't completely without merit. Maybe some of the connections there was slightly off, but everything wasn't wrong in what I did. So I'm still going to terrible line, but I'm going to draw it. And there's a property of tangents, I remember now, that says that this side has to equal this side. And if that's the case, then we're going to have SSS congruence. And so yes, they will be congruent. What matters now is if we can actually kind of do something useful with this, right? So let's try. We know that these are tangent as well, so this will be indeed r. Oh, wait, I'm dumb, right? So this is r, this is 4r. So I think that's a mistake that I made. This is going to be 5r, and this is going to remain 3r. So this part is now 4r, meaning that this part is now 5r. And so this part over here will be 15 minus 5r. And that's going to be equal to what? What did we have earlier? We had 9 plus r. Well, no, that doesn't seem right either. 9 plus r simplifies a little bit too nicely. I think, does it? Does it now? It does. Yeah, that's like that's too easy. And I don't, okay, maybe this doesn't necessarily have to be 4r. That could be the case. Also, did I do the math here right? 8 minus r, 9 plus r. Yeah, that seems fine. Yeah, I think it's like just tangents. I think it's literally just tangents over here. So if we can find this length, we will be fine. We just need to find the length. Um, how do we do that? So let me clear up some of the space here. Kind of go into detail, really lock this part down a little. Yeah, so that's really all we need here. If that's r and this part here is 4r, do they necessarily have to be, well, yeah, I mean, this is a right angle and this is also a right angle because they're tangent. And so if we extend this line, which we know to also form this angle here, it will be perfectly perpendicular to that. And if that's the case, well, now we've got a rectangle, right? Doesn't, it's obviously not a square, but given that this is r, this also does have to be r. Given that this entire thing is 4r, this has to be 3r. And so this little segment over here is nothing but 4r from the ratios. And I think that's, That's nice, isn't it? Did I do that right? 5r is the hypotenuse, 3r, 4r. So that entire thing is 5r. And this length is then going to be 15 minus 5r. Yeah, I mean, we're not getting anything messy here, so maybe we did mess up. But I mean, I don't think we've done anything too wrong here, right? The radius of circle, oh my god, 2. Maybe they actually just want n to be 1. Like, it is possible that they're just tricking us like that. You never know. Yeah, it would be kind of a dead giveaway if they just said, what is the radius? Because that's an integer. So maybe they're actually trying to dupe us, which is really not. Oh, wait, no, this seems like too easy though. Did I do this right? 9 plus r, 15 minus 5r. So 6 equals 6r, r equals 1. If that's the case, then this is going to be 5r, 4r. So 4r equals 4. 4 over 1, which is 5. Yeah, I mean, I'm sure there's something wrong here. Sorry, wait, maybe Steve, what are you talking about right now? The Okay, you got 5 over 7. Where did you get the over 7 from? Wait, I might have messed this up. I'm not sure. Because this does seem obviously a little bit too easy. So that's definitely this length is 8 in total. This length here is 15. This is 17. Since this is 8 minus r, that tells us this is also 8 minus r, and so this is also 8 minus r. 17 minus 8 minus r is 9 plus r. Um, this is tangent and this is tangent as well. So those sides also do have to be equal. Okay, if you guys think that I made a mistake here, just let me know because actually this is all the work we really needed for this question. And it seems right to me. Like I don't think I've messed up anything yet. I don't think anything's wrong here. Maybe I set this part up incorrectly, but I'm pretty sure that even this isn't. I think that's correct. I don't think it's wrong because the two radii from the circles that are perpendicular to the thing have to be parallel to one another and at the same time perpendicular to this and this. So that makes it a rectangle. The 4r makes sense, right? And just to be clear, this is how I kind of got to the next step. Um, all of these sides have to be equal to one another. That's kind of that's what I was getting at. Unless it's possible that there's a slight mistake over here, but I don't see anything off the top of my head. So I think I will go with this then. 5. It's not like I'm inputting my answers anywhere. I'm just writing them down. So let's go with that. Question 6 is 5. Let's move on to 7 now. Oh, doesn't look very pleasant or easy. Let's let's give it a go though. Actually, since we just did one geometry thing, maybe I can try another one and just see how it goes. Let triangle ABC have centroid G if GA is perpendicular to GB, AB is 12, and ACB is 30. Then blah blah blah, such that it's square free. Find A plus B. Okay, so let's draw it out at least roughly accurately. So this will be AC like this. GA, so okay, wait, it's a 30-degree angle, so something like this. Now we know that GA is perpendicular to GB. What is GB? GB is going to look something like that. Oh no, it's like from the middle, right? So it's like this. Oh, yeah, I mean this doesn't look completely impossible. That actually looks perfect. Does this look fine? Yeah. Okay, so I think this is fine. Yep. Okay, this looks good to me. We know that which one? AB is 12 and then ACB is 30 degrees. Okay, let's go in here. We know that this line also obviously goes through, right? Because it's a centroid. And if that's the case, this is going to be broken into 6 and 6. Not sure how useful it is to be doing those sorts of things right now, but we'll keep that in mind. Then AC times BC. Okay, so we need to find those lengths. How can we do that? Well, um, we can probably make use of the heights, I think, right? Because all the triangles that are made by the centroid have to be equal in area. And if that's the case, we know also that any two of them together will have the same area. And I think we can actually use, okay, no, let's make, oh, okay. So two of them are right, right? And so if that's the case, if these two diagonals are, if these two centroid, if these two medians are, I should label them actually, wait. So this is G. So yeah, I mean, this is like a nice triangle over here. This is also a triangle, triangle, triangle. So the entire thing is just a bunch of triangles. So there should be something that allows us to kind of do this a little bit more easily. I'm not sure what exactly that is though. Maybe it's that. Hmm. If we assign them names, I think we can work out some sort of relationship. Right, so the problem is again, I've drawn it a little bit too small, I think. So let's zoom out a lot. Try it again. Yeah, that looks fine to me. Okay. Pretend this is right. Yeah, it does. It's not perfect, but it's fine. If this is now the case, this is B. I think that's A and C. What else do we know? That I think that's all the information we're given, right? The 30 degrees is also given. We want AC times BC. How do we find that? There are a few different relationships that we can kind of use here, right? So this can be X, this can be Y. Now what do we do? Well, we know that um, if we were to draw this line over here, this is going to cut it into 6 and 6, right? Similarly, if we really finish off any of the lines, hmm, wait, okay, so each triangle is 1/3. That doesn't seem 1, 2, 3, 4, 5, 6. Yeah, okay, no, that definitely is the property. It's just that maybe it's not drawn perfectly. One of the first relations that we can derive from here is that x squared plus y squared minus 2xy cosine of 30 is equal to 144. So from this we can say that x squared plus y squared minus 144 over 2 cosine of 30 degrees is xy. That's one expression. We now need to just figure out what it is, right? So if we can find out x and y, well, I mean, no, obviously if we find out x and y, we're done. That's kind of stupid. So if we can find out x squared plus y squared in some way, we should be um, in good shape. How can we actually do that though? Well, we need to definitely make use of the fact that these are perpendicular, I think, somewhere. So one of the ways that we can possibly do that is by, let's call this like A, this is going to have to be 2A, and let's call this B, then this is going to have to be 2B. These are just on the ratios. Right now we know that um, sorry, we know that this height right here is going to have to be a as well, and this should be parallel to this, by the way. That I don't want to draw that in and make it more convoluted, but that's what's going on. We can also say then that this length right here is going to be b. Okay, so we seem to be a little bit closer now maybe to our answer. Well, if this is the case, do we not know that? Oh wait, no, no, that's makes sense. Okay. Well, what else can we do? What else can be said over here? Is there no other side that we can kind of work with here? This, by the way, should be a rectangle. It's just not very clearly drawn as such. But if that's a rectangle, okay, well, no, this also tells us that this is similar to this right over here. Let me know this. Yeah, I mean, it's just drawn very, very badly, so it's gonna be a little hard to deal with. Oh, if this is B and then this is B over here, then that's B right there as well, isn't it? I mean, yeah, this we could have figured out from long ago, but a squared plus b squared is 36. Right? We could have done 2a whole squared plus 2b whole squared is 144. That would have given us the identical result. This is one of the things. So, how do we proceed from here? We need to really be a little bit creative, maybe. Um, hmm. We know that all of them have to have the same area, right? And if that's the case, we can probably go ahead and figure out this height. Right? What is the height going to be? It's um sorry, it'll be 2a. So 2a times b is the area of 1. So this will be 6a times b or 2a times 3b. Whoa, that's definitely not right. Yeah, that has to be wrong. Okay, let's kind of go back to the drawing board. We know that the area of a triangle is AB. If that's the case here, then the height there has to be. Oh, okay, this might be somewhat useful. This is now going to have to be 2a. Maybe that helps and maybe it doesn't. I don't know at all. But okay, that's one thing, right? And now what else can we use to our advantage? We know that I think it would be this one, right? And the reason for that is mm, yeah, 3a, so then this should be 2b. Okay. Yeah, yeah, this works a little bit, I guess. Um, all we need to do now then is well no, yeah, actually building off of this. Since that's our base of 2b, the height of this right here has to be a. Wait, what am I doing? Wait. Yeah, no, obviously, because these are perpendicular. So this is A already. This is perpendicular, just like that. Yeah, it's terribly drawn. It's really messing things up, I think. But um, the thing is, if this is the case, okay. It's the halfway mark. So y is equal to a squared plus 4b squared, square root of that. Right? We can write that. I mean, sorry, that's going to be y over 2. So y is equal to 2 times this. right? We should keep that in mind. Now I think things are maybe getting a little bit easier, just because of the fact that um, well, okay, we know that it's a similar triangle that we're dealing with, right? So this length over here is also going to be b. Yes, that's going to be b as well. And when we have that as the case, we can now see that this obviously passes through the midpoint. So that tells us that z, sorry, x is equal to 2 times this. Oh, perfect, perfect. 4a squared plus b squared. Wonderful. How do we proceed from here though? It doesn't seem... Okay, so obviously we're going to go ahead and skip this. It might be possible to solve it with it, but it also might be... Oh, wait, it's probably easier to solve it using that, right? Because, okay, let's just bear with me for a second. X squared plus y squared is going to be 4 times a squared plus b squared plus... well, no, it's... Okay, so it's no need to beat around the bush. It's just going to be 5a squared plus 5b squared. What is 5a squared plus 5b squared? Wait. A squared plus b squared is 36. 4a squared plus b squared is 144. So it's all we're going to be left with is 21. So 16 times a squared plus b squared, which is 16 times 36, right? Because it's like 20 minus 4 times 36. Yeah, that seems fine. Divided by 2 times the cosine of root 30. Sorry, not root 30. 2 cosine of 30, which is 2 times square root of 3 over 2. And so this gives us 16 times 12 root 3, right? Yes. Yeah, that seems right, which is 196 minus 2, 192 root 3, and that's 195, I think. Yes. Okay, perfect. Yeah, the alternative to that would, I guess, be to just multiply them out. And when you do that, I have a feeling that you'd get... Let's try it. So we've got our answer of 195, but let's actually just multiply them because that should, in theory, be an easier way, right? I don't think we need to use the other approach. That would give us 4 times this square root, where we have 4a to the fourth plus we would have ooh, 17a squared b squared plus 5b, no, 4b squared. And yeah, I mean, I don't think this would be very pretty to evaluate. Actually, no, it does not seem nice at all. I guess you could write it as... you'd probably need to do some sort of manipulation. So yeah, this works out well. I'm not going to complain. I think 195 is the answer. And that's what, question 7, I think. Okay, no, that's question 8. Yeah, question 8. I don't think we're getting that far in this. Okay. Um, 11 seems deceptive. I'm not like some genius that I'm skipping all the way to the back. I'm just like trying to look and see if there's anything that might be a little bit more manageable because I'm gonna like hit the limit now in terms of what immediately I think, yeah, I will be able to solve it. Right. So 11 doesn't seem too bad. Maybe it is, but just like off the top of my head, I think maybe at least have some idea of how to do it. Right. At least I have an idea of how to visualize it, which would be something like this. So that's our tetrahedron. How do we want to draw it, right? Like, how do we want to assign the stuff? I think it's oh, okay. So there's a sphere inside this somewhere, and the sphere. Okay, no, that makes it a little harder. What I thought it was um there's a sphere around it, like this. Some yeah. So that's not the case. It seems there's something sitting inside it, which so there's a sphere that's going to be kind of inside it. And if we can find its radius or its diameter or anything like that, then we can find its surface area. That we need that information to figure it out. I don't think there's any other way. How do we get it to be tangent to everything though? Um, so okay, first of all, there are what? One, two, three, four, five, six. There are six sides. So it's going to be tangent at six different points. How do we even draw it? So one of the faces has to be um two, 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 four, four, four. Let's kind of think about how we could do this. If you have the four, I think you have to have it so that the smaller side is the two. Because if you have okay, so if you have the four like this, let me draw an actual equilateral triangle. If you have a four like this, and then you're kind of, you know, something like this, it's never going to touch these edges here, right? It's never going to touch them. And so I think it's vital. How can you be tangent to every edge? How is that even possible? How can you be tangent to any edge? Um, like, it's not really possible to touch an edge of a thing, is it? Because it's going to be it's like a हाँ मैं हिंदी जानता हूँ हिंदी में बात कर सकता हूँ हरिओम राज लेकिन ज़्यादा से आज के लिए मुझे लगता है ज़्यादा से ज़्यादा ऑडियंस अंग्रेज़ी भाषा में बात कर रही होगी तो शायद अभी नहीं करूँगा लेकिन दूसरे वीडियोस में मैं कर लेता हूँ हिंदी में बात कभी कभार बस आज ज़्यादा करने की कोई योजना नहीं थी मेरी okay so that has to be four but that still doesn't really answer my question let's just yeah if I can't even visualize it or think about it we probably have to skip that this one seems like I understand the question it's just that it seems very difficult to solve to me but I think it should maybe be something like geometric probability which would mean that it isn't super difficult right and what we have here is a square shaped cookie this is where the cookie by choosing 2 points on distinct sides of the cookie and cutting across the line segment form. So let's say you start over here, right? And this can be, obviously you can't pick anything on this side. Let's say you start at a vertex here. If you go here, what are the areas of all of these things that you want to take out, right? What is the area of each of those triangles divided by, so what's the average area of one of those triangles, right? And so to think about that, maybe we can just kind of logic it out. it should just be this triangle right here, I think, right? And so obviously the person who gets a bigger half of that is going to end up being, oh, wait a second. No, well, this first condition or case that we're examining is just much too easy because then it would be, um, if you're on a, so yeah, let's still write it down though. I don't think it's hurting us to know this. If you're at a vertex, you're gonna have, and because you're at a vertex, you're actually on two lines at the same time, right? So you're on two of the sides at the same time. So it's either that or the symmetric thing over here, right? And either way, it's going to be 7/8. We'll do the multiplication part later, but you'll have 7/8 of the cookie, right? So that's the first kind of case that we can look at. Now I think we'll get into the more interesting stuff, right? And that's where it'll get more challenging as well, but hopefully a tad bit more educational as well. So let's go like right here, draw it out nice and big. Okay, let's say you start randomly over here. To get to the 50% mark, and let's say this is the midpoint of your side, and then this is its kind of reflection along the when you rotate it, you'd have to have something like this, right? You'd have to have this right here. Okay, and now what is the difference in the areas that you, what's the difference in the areas? You could really just approach this by kind of finding um, how much. Wait. Okay, okay. I think I've got an idea of how to do this. You can write this as a function, right? And the way I'm going to do it is just like a function of x, where this is x. And it's going to be symmetric when you're on the other side. So we need only vary it from here up till here, and then thereafter it's all the same, right? I mean, we'll maybe have to multiply by something. We'll get to that later. But so it's like a function of x, right? And so um side length of 30 inches. I will put in a number just for now. So this is 15. And what you would have then, what you would have for this area is essentially, you would have 15 minus x. This should obviously be 30. So this is still going to be that proportion. Well, no. We should have it just as a fraction, right? So we just want the proportion. And so we're going to multiply later on by everything else, meaning that we should not be using 15. We should just be using 1/2 for this section here. If that's 1/2, what do we have here? That's 1/2 minus x. This is still going to be 1. So the area of this is 1/2 minus x. What's the area of this? This is going to be y right there. Right? Y can go from 0 until all the way until 1/2 plus x, right? If this is y. And so what is your average over here going to be? Your average over here is going to be um mm, actually the vertices don't matter at all. The vertex would probably actually end up giving us the exact same answer, right? And also, what did I even do with the vertex? I think I did it wrong because it's, no, I did that right, I think. Yeah. No, it's 3/4. It's not 7/8. It's 3/4, by the way. So sorry about that. Yeah. Okay. So that was my bad. It's 3/4, which I'm sure we would end up getting if we just did it. So yeah, once you have the general case with x, we should be able to find it a little bit easier to proceed, I think. So let's actually get to it then. X and y, right? So you can go from 0 until that height here. So this is going to be 1/2 plus x, because this is 1/2 minus x, right? These add up. And so what you'd end up getting is a half of this times x, and then times another 1/2. The reason I'm doing times half again is because obviously it's a triangle, right? So it's going to be a little different. So what does this give you? It gives you 1/2 minus x plus, oh, 1/4 times 1/2 plus x, I think. And what is this? Well, this is going to be 1/2 plus 1/8. That is 5/8 minus x plus 1/4 x. So it's going to be minus 3/4 x. Yeah. And so, the minus actually seems wrong now. I don't think that should be how it is. Um, hmm. What if I change x to like 0? Then 5/8 does make a lot of sense all of a sudden, right? What if I change it to something else? So wait, no, no. I think what we can do here is kind of um, mm, yeah, we need to address all different sides. So far, let me in a different color show what parts we've already considered, right? And so I want to do that like this. Little too thick. We've kind of already looked at this part, right? We've kind of already done this. So all that's left to handle is this component, which should probably just be one more calculation, and then this component, add them all together with the appropriate x values, and then we will see. So if x is all the way down at the bottom, we're going to have something like minus 3/4, 1/4. Yeah, if x is, okay, no, it makes sense, because if x is all the way down here, and we're averaging out the different possible areas that you're going to get here, well, first of all, none of that is going to work. Oh, wait, we're doing it wrong. Um, we have to break it up into different components, right? And we only consider the places where x is more than half, because Maria always gets the larger piece, right? And so to do that, all we have to consider is this section. Okay, so let's actually, like, instead of doing what we just, oh, oops. Instead of doing what we just did, let's kind of label out the section that we have to consider like individually, assuming this is your x. So obviously we have to consider this part. Right now, if we consider this, that's mm, that's actually kind of redundant, I think. Or is it? Well, either way, we'll have to consider it differently if we do end up doing that. Then we have this section. Everything here is going to be positive for us, regardless of wherever x is here. Wait, I just want to test one thing for myself. Is this the same thing as if, so if we go like this, won't, um, no, sorry, if we go like this, maybe, would that not be the same as? It's probably a little trickier than that. It's fine. We'll consider that as well. What we Maybe we need to let X roam over the entire site and then see what we can do with that. I think that might be the step that we have to take, actually. So, okay, let's draw it again and restart. I want to actually use this as an aid. Oh, oops. Yeah, I'm just gonna draw a little square and then see because I think um obviously on the test I draw it myself because I have to, but I'm fine drawing stuff like physically. It's a little harder on the computer here, right? Does this look fine? That doesn't look like a square. Think it's good now. Maybe a little thinner and then change this color to like white. Wait, wait, how do you? Oh, wait, the borders are different. Fine, yeah, we're good to go now. And so I'll also draw a little line right down. No, I'll do the rest by hand. Okay, one sec. Yeah, so now we're proceeding from here. And let's see what there is to do. Let's shrink the size down a little. Um, yeah, so as you're kind of going up this section all the way until the halfway mark here, anything that you take out from this triangle is going to give you more than half. I mean, there'll always be some side that's more than half, right? And so, yeah. At this point, you're going to end up getting 3/4. And at this point, you're going to end up getting what? You're going to end up getting a lot more than 3/4, right? You're going to get something like, no, sorry. At this point, you're going to get exactly 1/2. And when you're at this point, you're going to get 7/8 all the way until getting 1. No, sorry, that's 3/4. Um, this is 7/8. Yeah, so it's between, so you're going to go between 1/2, right? Everything here is like between, um, wait. So the way we want to do this is essentially like this. This is going to give you one of them, this is going to give you one of them, and we want to average it out to this, essentially. Right? That's literally exactly what we're doing. So this is going to be 1/2, this is going to be 3/4. So it's 3/4 times 1/2, which is 3/8. Um, uh, 3/16. Yeah, 3/16. After this point, once you cross, right now, anything like this, we already covered that in, wait, anything like this has already been, okay, wait, so we've done this side with that, right? And that gives us the average of all of this with anything in that square, really. So, okay, wait. Mm, okay, so this is 3/4. Um, it should be the average of 7/8 and 3/4. which is 13 over 8. 2 times 8, which is 13 over 16. 15 over 16 and 2, whoa, 14 over 16 and 12 over 16. 13 over 16 is the average for that one section. Same exact thing now. If you're over here and you go here, what is it going to be? Um, mm, you're now going to be going from 0 to, yeah, so now when you're going from here to here, you're going to actually have this entire area, right? So you're going, at this one it's going to be 1, at this one it's going to be 1/2, so that's 3/4. At, yeah, 3/4. At this point you're going to, so okay, wait, let's write that down as well. As you go down here, you're going to have 3/4. 3/4. As you go to this section, you're going to have 1/4. What does this give you? 3/4 plus 1/4 is 5/8. Yes, it is. And that's exactly symmetric over here, right? It's going to be the exact same thing. So 5/8 and then plus 5/8. So that's just going to give you 5/8. What we've now managed to do is cover how much stuff? We've covered this section over here with all of the top, and I believe all of this side as well. Right now, all that's left is this side over here. Okay. What would we do here? Also, it should then gonna be 3, and then we're going to add on something else. Yeah, okay. What do we get here? Well, if you go all the way over here, that's going to give you 3/4. And if you go until here, oh, wait, we don't have to do the same calculation every time, right? We can just, okay, no, 1 sec. You get 3/4 at this point, and then over here you're going to be getting like literally everything. So this is 7/8 when you're doing it like that. When you start over here, you can't get anything, right? So it's going to be 0 and 0. So no, it's going to be 1 and 1. So if you're like beginning to start, I think it's sufficient to go with this, right? That should work, I think. Yeah. And so what we see here is so at this point you're going to have 7/8. At this point you're going to have very close to the full cake. And so what that means is it's going to be 7/8 um plus 1, average of that, that's 15 over 16, which is a lot, right? That's like a very close to the whole thing. And that only makes sense because you're getting a very big section of the cake from that. The person who gets more is going to get a lot more than the other person is. And now it's kind of would these other things not be symmetric? Like, have we not already considered the other cases? What if you were here and you went here? I think we consider that when we went from the other perspective. And so I think this is literally, that's it. That's all we have to calculate now, the average of this. And once we calculate that, we will figure out the correct answer from there, which is just like a little bit of maybe algebra. So let's get a common denominator. 12 over 16 plus 10 over 16 plus 15 over 16, all divided by 3. Let's see, so that's 2537 over 48. Not looking too good in terms of the calculations, but so if it's 37 over 48, how much extra of the cake are you getting here? And you are getting quite a bit extra. The other person is going to get, so it's 37 over 48, and the other person is getting 11 over 48. So the difference in this is 26 over 48, which is nothing but 13 over 24, right? And now our job is just to multiply this, which, hmm, yeah, wait, this seems a little wrong because they're not going to get an integral answer. We're not going to get an integer answer from this, which is kind of a problem, isn't it? Um, we worst case we'll go back and check our calculations. Let's start with these calculations. Times 4 times 4 times 2 times 2. This adds up correctly over 48. 37 over 48 minus 11 over 48 is 26 over 48, which is 13 over 24. Oh, 26, 11. Wait. That's a difference between the two. So 13 over 48 plus 11, then 37 over 48. Yeah, I mean, I think that works enough. That's like a lot more, though. Okay, our next job is then just multiply this by 30 times 30. Well, yeah, 3 times 4 times 2. And this cancels out to give us 15 times 15, 15 times 5. So 65 times 15 over 2. That's obviously wrong because it's an integer amount, right? But at least now that we figured out what we want to do, let's maybe try again in the calculations, right? And I think what we'll have in the calculations is actually something very similar to what we just did, right? So let's start with this side over here. What are we going to have? We're going to begin with something like, um, oh, maybe I did the 3/4 wrong. The 3/4 actually seems wrong over here. I don't think that should be 3/4. I'm actually thinking it should be the exact same as what we just did, which is 15 over 16. Oh, no. Okay, so this is going to give us 1/2. This is going to give us 1 whole. This is going to give us 3/4. Is it not 13 over 16? Like, what was I doing? Obviously, something wrong. Right? Yeah, let's try again and see. I think the other stuff is fine. The 5 over 8 looks fine. The 15 over 16 looks fine. This shouldn't be 16 over 15, but it shouldn't be this bad either. Right? So, what I think it should be is 3/4. No, okay, no, it is this. This is the exact calculation I did. Because this is going to give you 3/4, I think. This is going to give you a full one, right? And because that's the case, you're going to end up averaging that out to what? 7 out of 8. And so when you do this, you're going to get 13 over 16. Yeah, exactly. 13 over 16. And now when you add it, I think you'll get um 28 plus 10 over 48. So that's 38 over 48, which means that so the other person is now going to get, that's 28 over 48. That's a ratio that you're averaging each time. And this actually does simplify quite nicely. You can take out a 4 from everything. So that's 7 over 12 times 30 times 30. So 7 times 3 times 3 times 2 squared times 5 squared. Does that seem right? It's 3 times 2 times 5, which is 30, times 3 times 2 times 2 times 5, divided by 2 squared times 3. So 2 squared goes away, 3 and 3 go away, and you're left with 21 times 25, which is 525. Yeah, that's good. No. Oh, wait, no, that seems right. That seems right. So 10 is 525. Okay. Not too bad if I yeah, not too bad. Let's take a look at question 7. That's probably the last one that I'm capable of doing. Actually, I don't want to undersell myself here. I mean, it's not. Look, the point is, I might have made a few mistakes and needed some help, but I have still been able to do most of these. Um, well, it's Wizard. Sorry, I'm just seeing your message now in case you said it earlier. Regarding grade level, it's not necessarily like it's not for any specific grade level. And if you're in America, then you might know about it. Otherwise, you might not. But it's like the AIME exam. So it's usually for high schoolers, either in to qualify for. So okay, AIME is American Invitational Mathematics Exam. Right, to get invited, you have to do well on the AMC 10 or AMC 12. Those are for 10th and 12th grade. And if you do well enough, but you can take them earlier. Like I know of people who are in like 7th grade who do very well on AMC 10 and can take it. But I think typically the people who take it are like either in like ninth, 10th, just in high school, ninth, 10th, 11th, 12th. But it's supposed to be challenging. So it's like it's not like a school level thing. It's definitely harder than what you might see at school. Like yeah, I mean you might see something like this at school, but obviously these later questions like this one that we just did, whether we did it right or wrong, I don't know. But the point is like this isn't something that you'd see at school. It's a lot harder than that. Okay, anyway, let's proceed with question 7, and I think this will be the last one. I have to do some other work as well. I have homework due, so I won't be spending much more time on this. Let's give this one a go though. Let's at least try to see it and try it and see what we can do, because I don't know if we'll be able to actually do anything there. Given a positive integer k, let s of k denote the sum of the digits of k. Let a1, a2, a3 denote the strictly increasing sequence of all positive integers n, such that s of 7n plus 1 is equal to um, 7 times s of n plus 1. Compute the remainder when a sub 2023 is divided by 19.9. Okay, so we want to find the 2023rd term in this sequence that satisfies this, right? And so what is the sum of the digits of k, right? Yeah. So the sum of the digits of k, what is that going to be? Um, S of 7n plus 1. Okay, wait. Let's try this. A little. Let's see. What are some possible numbers that might work for this, right? If you have something like 10, this will now go to 71. The sum of the digits of 71 would work. So 10 works. That doesn't really tell us much, though, right? What about even just the number 1? Would 1 work? 1 would work as well. Actually, wait, that might mean something. Think about it, right? If you don't have a 1, um, so when you multiply by 7, either you'll keep the same number of digits like this. So we kept it to 2 digits, or you'll add another digit, right? If you add another digit though, you're gonna have something like 6 times 7, which goes to 42. And so you're losing out here, and your sum is most likely not going to be as much as it would have been earlier, right? If you have something like 61 times 7, what does this give you? This gives you 426. And this is um, obviously not 7 times as much as this, right? Like the big difference there. So that suggests to me, because we got a 7 times s of n, that's like a huge difference, right? So you want s of n to be small, but s of 7 and plus 1 to be a lot bigger than that. And I think for that, it's necessary that you have only ones and zeros. So you can have like a 1 and a 0, and that works. What if you just have 0? Well, okay, that won't work because k is a positive integer. So, but what we do have is that 1 works, right? And so if 1 works, what about some of 1's neighbors, right? So 10 would work. 11. What would I don't think 11 would work, but it might. 7 times 11 is going to give you 77. 77 plus 1, 78, which is 15. And over here, you would just have 7 times 2 plus 1, which is 15. So 11 also works. So from this, what I'm getting is if you have something that has ones and then all ones and zeros, it should work, right? And so over here, we would have 101. Sorry, we would have 100. We would have 101, right? And actually, I'm going to write out a few more possibilities, and then we'll actually go and check them, just so I can be sure, right? But what I'm sensing here is that yes, indeed, it does work. Okay, yeah. This is going to be 3. So uh, s of 111 is 3. So 7 times s of 111 plus 1 is going to be 22. What if you multiply this by 7 and added 1? You'd get 7, 7, 8, which is also 22. So yeah, it does work. And I think the same can be said for all of these, meaning we've made some progress, right? So 1 works, 10 works, 11 works. For 1 digit, there's 1. For 2 digits, there are 2. For 4 digits, there will be, so for 3 digits, there will be 2 to the 3 minus 1, which is, let's write them out. 100, 110, There are 4 of these. For the next one, you will have 5. Sorry, 2 to the 4th, which is 2 to the 3rd, which is 8, and so on, right? So now you've got 1 plus 2 plus 4 plus 8 plus and so on. How do we get to 2023? Well, we know how to get to, uh, wait. We know how to get to 2048. Sorry, 2047. To get to 2047, you'd be 1 plus 2 plus 4 plus until 1024, I believe, right? Because you'd get closer and closer and closer and closer, and if there was another 1 here, you would now get to, this would become a 2, so this would become a 4, this would become an 8, so, and that'll give you 2048. So this is equal to 2047, right? What is 1024? Which set would give you 1024? Let's, to get 1024, give me 1 second. Sorry about that. We'll resume now. Okay. Let's continue. I think we can actually do this. 2047. So 2004, this would be to get 2 squared, you have 4 digits. To get 2 cubed, you have 3 digits, right? Yeah, for 2, um 2 to the first gives you 2 digits, this gives you 3 digits, this gives you 4 digits. So this is 2 to the 10th, which would mean 11 digits. Okay, we've got 11 digits. How do we kind of rectify that? Well, I don't know why I said that. If we have 11 digits, the very last term that we're going to have is 11111. That's 5, 6, 7, 8, 9, 10, 11. Long number, right? Fortunately for us, um, Yeah, like fortunately for us, this is the same thing as I don't know. Give me 1 second. Yeah, I mean, to go one number down from this, you would do this. No, I think I'm pretty sure you can use binary over here. And to subtract 23, wouldn't you just subtract? Okay, if you're subtracting one, you'd do. Okay, you know what? Yeah, we can. So this is 1, this is 2, this is 4, this is 8, and then this is going to be 16. So what is 23 going to be? 23 is going to be 1, 0, 1, 1, 1, right? 1 plus 2 plus 4 is 7 plus 0, 8 plus 16. That is 20, 23. That's 23. If we want to subtract it, well, I mean, that's easy enough, right? It's going to be 1, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0. Isn't this going to be the case? This should be what we have, right? Because essentially yeah, because it's strictly increasing it's a strictly increasing sequence. So 22 would now be no, wait, am I? No, I think I'm right here. Yeah, I think this is fine. The number immediately before this would be yeah, I mean, I don't really know how else to do it. What becomes a little troublesome now is doing what? Finding it mod what they said something right? Divided by 999. So this is obviously going to be 1. I want to put some commas so it's a little easier for me to see. Times 1,000, right? So this is going to be times equals 1 times 999 plus 1 same exact logic here. It's going to be 1 times 1 plus 101 mod 999, which is 1 1 wait, what? Oh, times 1 plus 111 plus 101. Yeah, don't mess me up here. 101. And that's it. I think that's it. Right now, what do we have? We've got, let's not mess up in our addition. This will give you 212 plus 11, which is 322, 223, right? Yeah, 223 is correct. Yeah, I mean, that was a pretty long, whether I did it right or wrong, at least like this was a very nice question, I think. It was very, and I might have gotten the premise completely wrong itself, right? Maybe that's what did I say? It was 223, right? Maybe I just messed it up completely. But I think I still got some practice with at least some of the things from that, right? Also, regarding time, let's see, how long is the stream been? The stream has only been, it's not even been 2 hours of me streaming this. So obviously the questions only get harder and harder, right? But the like that's I've still got, if I was actually taking the test, I'd still have 1 hour left. And in that 1 hour, I would be able to maybe try obviously I would guess I'd guess all the questions, but I'd still be able to like try and maybe do one more. I don't have the time right now, and that's obviously not an excuse, but let's see. Wait, I'm pretty sure the answer for 4 here is wrong. I'm pretty sure that wasn't my actual answer. Yeah, wait 1 second. Was that that was not what answer, that was not the answer that we got, was it? This the sum is 36. I don't know where the 4 came from. 1 second. Yeah, that should be fixed. It was because I remember, because that was not 36. I think the other answers now should be fine. Let's go and zoom in a lot. Okay, 490, 80, 182. These are also okay. Then 36, 17, 27 instead of what? Instead of 5. I think that's the one where I said, oh, it's just an integer, when obviously it wasn't an integer. But I think one of you guys said, okay, let it be 7, 333. Oh. Actually, let me check my calculations because it's possible that I just did something dumb here. Because it seems too close to what we did to be, completely wrong. So let's go ahead and try this once more. Hmm. At the same time, like I think I was just very, very off on this. Um, it would be 110 more than this. So, yeah, let's ignore that for now. Let's see. We still did a few more questions. Right now, I think what we're at 5 or something. That's pretty bad. Okay, 8 is correct. What is 8? I remember that one. Yeah, no, I was actually confident about that one too. I didn't think I got that one wrong. 9 we didn't do. 10 we did 525. Ooh, okay. Let's take a quick look at 10 and see. Um, how would I be off by that amount? That's 1/16th, I think. That's no, it's not 1/16th. It's 1/36 of the total area. So our final answer is off by 1/36, which is a pretty mm, okay. Yeah, maybe we can do some error analysis later on. Let's mark the ones that I got right, right? And there were a few of those. I think we got the first 5 all correct. We got 8 correct. We didn't try 9 or 11. So this is like a final score of 6. Not not terrible, but not good either. I want to see 6 now because I want to try 6 again. I kind of already forgot their answer. It was definitely 27. 27 was their answer. Let's see if we can't get that ourselves as well. This will be the last thing we do in the stream today. Let me check. I think, wait, someone had, oh yeah, maybe Steve got the right answer. The right triangle connecting the circle's centers is similar to, okay, yeah, 20 over 7 would have given you 27. So I'm guessing maybe Steve was right. Let's see what he might have done. Externally tangent to each other. I have a drawing for this. I should just use that, shouldn't I? It's this one. What did he say? I'm just checking the chart right now. The right triangle connecting the circle's centers is similar to 3, 4, 5. There's no, where is the right triangle? Okay, this one is similar. Why is it similar though? Maybe because it's, wait, yeah, I don't immediately see why that has to be the case. Like, also, I don't see what we did wrong in our approach here. What I did wrong in my approach here. Let's continue from where we were here. We That square seems right to me. This is 5. Oh wait, no, no, we got that right. It's a 3 4 5. Wait, wait, one sec. What did he say? He said is the right triangle correctness circle centers. Okay, no, no, yeah, no, we got that as well. We got 3 4 5. Yeah, that's fine. That's fine then. Um, does it even work what we did? I don't know if it does. What did we get? We got 4. That would mean that this is 16 and this is 13. That would make this, was it 15 minus 5r? Yeah, it was 15 minus 5r, not that. No, wait, I'm so stupid. It was 15 minus 4r. I don't actually, the stupidity thing is separate. I don't think this makes it right either. It was 15 minus 4r though. No, wait, no, it was 5r. Okay, sorry. This is 4, this is 5. So 15 minus 5r. Um, yeah, I mean, and then you'd find that length. But I don't know if it's necessarily correct. So we're going to actually test that out now with some. So we got r equals 4, right? And if that's the case, what does that tell us? Well, okay, that does not look right. That obviously that can't be right. No, no, no. We got r equals 1. We got r equals 1, which will make this 7 because what we got was 4r equals 4. If this is 7, this would also be 7. This would also be 7. This would be 4, 5. BC is the side which is 15. Yeah. CA is 17. Did I add it up wrong over there? No, I didn't. That looks fine. 5, 8, 15, 17 is a right triangle. Externally tangent within. The radius of circle omega 2 is 4 times. Find, yeah. Circle omega 1 is tangent to AB and BC. Yes. So, and the other one is BC and CA. Fine. The radius of circle omega 2 is m over n, where m and n are. Okay, so what could we have done wrong over here? Let's kind of brainstorm and see. Like, if it's some stupid algebra mistake, then obviously I'll be disappointed, but I don't think it's that bad. But like my logic here doesn't seem wrong, and I know obviously if you're just tuning in, doesn't look like there's much logic. It's pretty, messy over here. Um, okay, so I have a feeling the triangle that I made connecting the centers might be off a little bit. Sorry, sorry. I'm not sure why though. Like it doesn't seem wrong to me, inherently wrong to me. Let's see. Let's brainstorm. So it does have to be a right triangle because of the way let me redraw it because I don't think this, looking at it is obviously going, oh, I drew it better over here. The circle, and then that's also equal to this side because it's again tangent to the circle. But now looking back, are those assumptions all correct? And if not, how do we solve it anyway? Because someone in the chat got it and like they would have told me if I was making a big mistake, I think. I don't think I was. Maybe it is just a calculation error, right? Because if you think about it, that's probably more. Okay, wait, this was 7. So if this was 7 and this is also 7, we know that this side length is going to be 10. This is going to be 10. What are they asking us for? Yeah, the radius of circle omega 2 is m over n, the radius. So, okay, obviously that's not, we're doing it wrong. We're doing something wrong. Um, because it's tangent there and there, does that mean necessarily? Well, yeah, I mean, because it's a right triangle and because it's tangent, this does have to be a square. So this part I think is 100% sure about this. What then I'm not sure about is Can we do something similar to that over here? Also, do these have to be equal? I think they do have to be equal because it's like two tangent lines will have the same length, regardless of, well, wait, what if you're coming from here? Yeah, I think that should remain the case regardless. Which leaves, then that only leaves like one question really. Why is it wrong? Right? This is going to be R. They said it's 4 times the radius of circle omega 1. So if that's R, this is going to be 4R. This is going to be 4R, right? Perpendicular right here. This is going to be 4R. And this is going to be 1R that we're taking off. And so this entire thing is indeed going to be 5R. If this is the case, if it's, sorry, 5R, 3R, and if this is 4R, what do we do from here? 4R plus R, which is 5R. So it's 15 minus 5R over there. Wait, does anyone know what mistake I might be making here? Anyone? Because like I think it's been like 10 more minutes that I've been just looking at this and I still haven't figured it out or made any progress at all. So I'd appreciate it if anyone could like point out a mistake here because I'm sure there is something dumb that I've done here. Whether it's like an assumption that I've made or just generally like some calculation type of error, let me know please because I don't think my approach in the question was wrong. And to be honest, there's really no other approach I can think of or want to put the time and effort into implementing. Let's see, triangle ABC has side lengths AB is 8, 15, and 17. So that does make it a right triangle, right? 64 plus 229, 289, which is 17 squared. CA. Did I label my sides correctly? It should be like this, right? A, B, and then this is C. Yeah, I mean that way it looks fine. Now they're externally tangent to each other and within okay, that's also true over here. If they're tangent, does that mean that any of the assumptions we made are wrong? I don't think so. Oh, wait. Um, the problem is that okay, I see. Yeah, I just drew it like so fat over here that it was wrong. This triangle is no, wait. Okay, I thought I'd made some dumb mistake there. I don't think I have yet. Well, maybe I have. Like, think about it. If you have what I've done over here, this means what if you do something like this instead? They're not touching over there, they're touching over here. That's the problem. So that doesn't work and it doesn't make any sense either. So it doesn't make sense. What have I messed up here? This is so just to be clear, this is 4R. I know I wrote 5R, that was reference to the whole thing. Because this is R, this is 4R. The whole thing has to be 5R. Right? It has to be 5R. The other one is 4R minus R, 3R. Is there any other possibility? Is there anything else that it could be? Maybe that um did I draw my tangents correctly? I think I did. I think I did. And the whole side is 5R. And so Did I do this right? 8 minus r goes until that edge, and then that is also 8 minus r, which goes until there, and then so that's 8 minus r, which goes until there. If it's 8 minus r, what is 17 minus 8 plus r? That's 9 plus r. And then what is 15 minus 5r? That's obviously also same thing. It doesn't make sense here. Did I um did I draw the circles wrong? Because that's really the only other possible mistake I can think of at this point. If I drew, is it even possible for the circles to look the way they're looking right now? Maybe I just drew it so badly with regards to scale. And yeah, that's believable. Right now it's like only twice the radius. Let's go back to the drawing board, literally, and try this again. And this time maybe let's use some like straight lines and see what we can do with that. No, never mind. We'll just draw it by hand. $15, about half of that, which is 8, a little bit more, 17. There's one small circle here. Maybe for a circle I'll use some help. Actually, no, it's annoying. I don't want to do that. Let's draw a small circle here, perpendicular at this point, perpendicular at this point. This is now, it has to be a square. Because it's a square, this is R and this is R. Okay, now our second circle is going to be something like this. Yeah, okay, that's obviously not a good circle. Let's try, so which should just be further to the right. I want to make it a little bit more accurate this time, so at least I can, um, in case there are any like dumb mistakes that I'm making that I can spot with this. It's such a dirty lump. It doesn't even look like a circle. That's better. Okay, it's still pretty bad, but I'll deal with it. This is going to be R because they're perpendicular. Oh, the tangent does not necessarily pass through it. Okay. Okay, wait. Who said this has to be tangent? It doesn't it? No, it doesn't have to be tangent at all. So, okay, this goes here. The point that this is tangent to this circle does not have to be this point, does it? It can be like right here. Well, no, I mean, it kind of, let's see. Um, I mean, I'm getting that point. Does it have to be that point? I don't, I don't know. Let's say for now that they're not, and if they are, then we'll have to prove that. We know we can still, okay, so all this logic still holds, I believe. This perpendicular is going to be just like that. So this is 3r. This part does make sense, and this will end up being 5r. And then this part over here will end up being 4r. 4r. Similarly, we have this section over here where this is 4r. Right, we can kind of draw this line in Yeah, I really don't think it's necessary that they have to be the same point. And if they are, that shouldn't really stop us, no, should it? So yeah, I mean, this is now, I think this is established to have to be 15 minus 5r, sorry. What would we have over here then? What would this be? Maybe now is the time to use similar triangles. Oh, wait. Maybe we can um extend this out like this and see if we get anything with that. Right? Because now essentially the radius is going to be 5r plus root 2. So 5r has to equal whatever we get now, which is going to be 4/5 of 5 plus root. Well, no, obviously this isn't even true. So yeah, okay, now scratch that. No reason for that to be the case. Let's just erase that stuff altogether. What else can we really do here? This is okay, maybe you can work backwards, right? This is 15 minus 5r. That tells us that this is going to be 2 plus 5r. No, we're getting the same thing. Okay, yeah, I'm done with this. It's getting annoying now. Geometry round problem 5. Fine. We're going to find the let's see. Yeah, I've wasted way too much time on that. It's just getting like, it's annoying now. It's probably in here somewhere. No, not this. This one. Geometry. Yeah, and it's only question 5. It shouldn't even be that hard. Oh, why did I go here? It should be the solutions. So, question 5. Oh, they changed it slightly. But yeah, that doesn't change it. The answer is still correct. Okay, so by the height of triangle AQB. Oh, what did they do? Let P be the center of omega 1, Q the center of omega 2. So this is, let's label our stuff then. Let me get rid of my little annotations and just see what the solution is, because obviously they're correct. Let's get rid of this. Yeah, let's just get rid of all of this actually. Okay, let P be the center of omega 1. Let Q be the center of omega 2. Let the radius be R. Yeah, okay. Divide triangles A. So wait, what is it? What was A? This is B, right? So A, B, C. PQ is 5R. Yeah, fine. We also established that, right? Oh, okay. So they're saying divide into AQB. That's AQB. BQC, and then obviously AQC. Fine. I want to understand what's wrong with my approach. Maybe I can feed this to ChatGPT and see. Because, or if any of you can point out any mistakes there, that would be great as well. Right now it's open solution. I'm just looking at the solutions because it's the test itself is not open note. You just pencil paper and then like maybe a straight edge or something. Key idea is that the heights of these triangles are multiples of r. Mm, what do they mean by that? The height of the triangle with what? Oh yeah, okay, yeah, yeah, I see. Yeah, sure. Yeah, okay. Divide the triangle into these. The key idea is that the heights of these triangles are multiples of r, and we can use the areas of the triangles to find r itself. Fine. Since circle omega 2 is tangent to BC and CA, like I've drawn over here, the heights, um, the heights of triangles BQC. Yeah, okay, both these are 4r. Okay, what next? Of course, it remains to find the height of AQB. Let Z and Y be the points of tangency of BC to circles omega 1 and omega 2 respectively. So this is going to be X. This is going to be Y. Okay, what now? There probably something like PX. Okay, PXYQ is a trapezoid, blah blah blah. 5 by the Pythagorean theorem. XY is equal to 4R. Yeah, okay, we got that as well. So the fine, yeah, I got that too. Find the height of triangle AQB. What will that be? Um, that's that's not immediately obvious to me. Let X and Y be the points of triangle C. Okay, we did that. BXYZ. So the height of triangle AQB is BY. Wait, what? BY, which is BX plus XY. Y. Oh, wait, because it's okay, I see. Because it's right, right? Yeah, so this is going to be 5R. Okay, let's finish it off ourselves from here. At least we can save some face, right? So 5R times what? 8. So, okay, like the base and height of the original triangle multiply to 120. So the area is 60, but they multiply to 120, which is equal to 8 times 5R plus 4R times 22, right? Because that's 4R times 15 and 17. No, that's 32. Never mind. 4R times 32. And so 120 is equal to 40. So that is 128. So 168R. Divide it. Take out a 4. You would get 30 divided by 34. Wait. No, 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 no. Divided by 17. 168. So no, it's not that either. What is it? It's sorry, 168 is equal to 30 divided by what? 25 plus 17, which is 42. Take out take out a 3, and now you would get take out a 6, and you would get 5 over 7. Fine. And then you multiply that by 4 for 20 over 7. Okay. So I mean, I think I did all the stuff. What I made the mistake of doing was thinking that it's easy and you can just use the tangency stuff, which, to be honest, didn't, I don't know if it was, obviously it had to have been wrong if I got the wrong answer using it, because I think my steps and the logic, if it were right, my logic would have been fine as well. So the lesson there is that I don't know my, that level of geometry for circles well. So I guess I'll work on that. But okay, at least like solution wise, it makes sense, and it really wasn't a hard question either. So that's good. I'm how did I get the question 5 wrong as well? That would be pretty sad. No, I got 5. Yeah, I mean, actually no, I needed Rohan's help with 5, I'd say, because I was off on like this, right? Which obviously I think that made it a little bit more convoluted. Really, I don't think I needed anyone's help. I was at this stage, and then I kind of messed around from there forgetting that I can break it up into two, right? That would have just been two nice and easy geometric series. I would have been able to figure out how to simplify this. So this is like the where I made a mistake. I mean, I still got the question right, but that was after. And I might not have gotten the question right. I'm glad that I got at least to this step after the setup, and so the idea that I had was fine. Same thing with four. With four, I don't know what else I could have done. Yeah, just one through eight, and you add them up and see. So that actually wasn't super difficult either. What I was doing initially, I think, was just listing out all the factors of 20. Uh, no, never mind. Never mind. That was like some. We won't talk about that. Seven. I don't know. I don't know what I did wrong in seven. I think my logic was right though. For the most part, what I could have messed up is possibly the number of zeros that I had, or just the way I wrote it because there were so many ones. That's probably one possible thing. Let's try it again and see. Like just the calculation stuff of this, So, I mean, if we're off by just one number, that could change everything for us. So we didn't even look at this one. Like, yeah, not even a glance. It's fine. How did I get this one wrong? I mean, like, to be honest, it's question 10, so I wasn't really expecting the most, but oh, I saw. Okay, no, wait. I think they're just reusing all the questions from here because I saw this part of the question elsewhere. This part. And then they just added this obviously to make it adhere to the AIME format. Okay, I mean, I did the first few questions right, right? That wasn't super bad. I was able to do five of them, right? Five of them, and that too relatively fast. I think six was within my capacity. Seven, I should have been able to do. Eight, I did correctly all by myself, so I'm proud of that. And then 10 was kind of, I don't know if my approach was right. I think at least the idea that I had of like putting it down and proceeding from there, whatever, it wasn't too bad. Time wise, yeah, I mean, a lot of it was just talking and kind of idling away. But I don't think the time limit should be a problem. I just need to like improve enough that I can actually solve the harder questions at the end, right? And improve in all aspects. Like geometry, obviously, I can use some work there, but also number theory. Like I was too scared to try this. I still haven't looked at it, and now it's I think too late. I've got other stuff to do. This one I couldn't even visualize, so definitely 3D geometry. This is algebra. This is again discrete math, geometry, and then I don't even know what is this. It's probably a mix of discrete math and algebra. So no, I'm not in college. I'm in high school. In like about halfway through 11th grade. Okay, I think that's it for today. I don't want to take too much more of your time or my own. I will definitely do more of these. Like there's another BMT to AIME 2022, which I have open right here. Maybe it's harder, maybe it's easier. I have no idea. It seems a little longer. It's 4 pages long this time. 3 pages of text. So we'll see what we do next time. I should be making more videos this weekend, most likely. So let me like turn that off now. Yeah. So I'll most likely make more videos this weekend. So like today, tomorrow, and depending on where you are, like different days. So I'll probably work on that. And then besides that, that's it. If you have any suggestions for future videos or anything like that, let me know in let me know in like this chat thing over here, or you can let me know in another video in the comments. I get like notifications for comments, so I'll see and I can like act accordingly. I also have like IIT videos and that sort of stuff. A lot of them are kind of in progress or that I've done. I've done the questions, I've got them already. I just haven't had the time to record it because recording, frankly, like recording, editing, posting takes a long time. So I kind of prefer doing live streams right now. So I don't like spend too much time on editing and that sort of stuff. But yeah, definitely let me know if you have any suggestions or any tips on what might make things better. Thanks so much for watching though. It's been 2.5 hours now. I'm not trying to take any more time. So I think we'll call it a day here. Let me shrink this, put it back to its regular size. Yeah, okay. I think that's